Here is a problem that mixes solution stoichiometry with limiting reactants, and the reason we know that is because it's giving us a certain quantity of AgNO3 and a certain quantity of K2SO4 that are mixed. So both of these chemicals are needed to produce the Ag2SO4. The question is which one's going to run out first. So there are a few ways to approach this. Again, you can use the ice chart method or the double fence post method. I'm going to use the ice chart method for this one, but again, you can decide how you want to approach it. So I'm going to start by writing out the reaction as I do in an ice chart problem. So Ag2SO4 plus 2KNO3. But remember, the way ice charts work is you're supposed to write the moles of the chemicals under the line. So I'm not given the moles of AgNO3, I have to calculate that. So that's the first thing I'm going to do. So I know I have 400 milliliters of AgNO3, and I know that there are 1,000 milliliters in 1 liter, so I first have to convert it to liters, and I know that 2.5 molar is another way of saying 2.5 moles for every 1 liter. So that will let me convert that to moles. So I will do that, and I will find that there's 1 mole exactly. Okay, so 1 mole of AgNO3 I will write in there, and I'm going to do the same thing with the K2SO4. I'm just going to assume that you can do that. I'm not going to do the whole thing, but I'll get 0.9 moles. So that's how many moles of your starting chemicals you have. Again, you start with 0 of the products. So the question is which one's going to run out first. So again, there's more AgNO3, but again, it's used at twice the rate. So 1 versus 0.9, I'm going to guess that this is going to run out first. Nope, I made that wrong. I'm going to guess that this is going to run out first because it's being used faster. So if that drops at a rate of -1 because of the 2-to-1 ratio, this is going to go down by 0.5. So that means this is going to go up by 0.5, this is going to go up by 1. So there'll be no moles of AgNO3 left, there'll be 0.4 moles of K2SO4, 0.5 moles of Ag2SO4, and 1 mole of KNO3. And again, you don't have to do it the ice chart way, you could do it the other way too. But so clearly the limiting reactant is the AgNO3. So I'm going to be producing 0.5 moles of Ag2SO4, and the question asks how many grams, so I'm just going to convert that to grams using the molar mass of Ag2SO4, which is 311.81 grams. So I'll just multiply that by 0.5. So this will produce 155.91 of the Ag2SO4. And that is it. So this is solution stoichiometry. Really isn't a lot different from regular stoichiometry. Again, you just have to be able to get your numbers to moles, and then it takes off and does exactly the same thing as before. Just be able to recognize this is a limiting reactant problem because, again, you're given info about both reactants, so one of them is going to run out on you first. So until next time, I am Derek Genova. Have a delightful day.